Okay, so this video is going to be about addition and subtraction of matrices. So the very first thing that we need to know about the addition and subtraction of matrices is that to add and subtract them, they must have the same dimensions. Okay, so if you're going to add two matrices together, they must both be the same size. So we can add a 2 by 3 matrix with another 2 by 3 matrix, and we get another 2 by 3 matrix as the sum. We can subtract a 3 by 3 from a 3 by 3 and get another 3 by 3. Okay, but those dimensions must match. The reason why they must match is because you are going to add or subtract, depending on the problem, you're going to do it by elements. Okay? And those elements are corresponding. I highly recommend graph paper. And if you want to, like colored pens and pencils, things like that. Okay, so let's just try like a really basic one. Okay. So first example, we're going to add 15, 13, 0, and -2. That's a 2 by 2 matrix. And we're going to add a second matrix. We're going to get a -12, a +11, a -7, and a -5. Okay, and we're just going to add those. Okay, so what you want to do is you want to be very careful and just match them up. So you're going to go 5 plus a negative, or excuse me, 15 plus a -12. Okay, then the next one, 0 plus a -7. 13 plus an 11. And then -2 plus a -5. You don't have to write all of this out if you don't want to. It is perfectly reasonable, I think, for you to do this in your head. Okay, so our answer is going to be, let's see, 3, -7, going down the column, 24, and -7. And that's it. We're done. Okay? So if you want to do a larger one, I'm going to do this one by hand or in my head. So I have a 3 by 2 matrix. And then another 3 by 2 matrix. So if I add those up, I just match up my entries. So 1 plus 11 is 12. 15 plus a 3 is 18. -7 and an 8, that's a 1. Next column, -11 and -15 is a -26. 13 and 20 is 33. 8 and 1 is 9. And then you are done. Okay, so it's not that bad. All right, now to subtract, okay, we're going to talk about adding the opposite. Basically, think of it as distributing a negative. So all that happens with subtraction okay, and again, you can do this in your head as well. Is your negative is going to change the sign of everybody behind it. So what you could do, if it makes it a little easier, is you can think of it as distribution, but it's really not distribution. So change that to a plus. And then remember to change all of the signs of the matrix behind. This is called an opposite matrix. It's just changing the sign of every element. Okay, so our result is going to be 11, -7, 0, and 9. So Edgenuity talks a lot about how subtraction is just like adding the opposite, and that's exactly what you're doing. Okay, so let's write down a definition for an opposite matrix. An opposite matrix will have the opposite signs of every element of the original. Okay? All right. So things to know about addition and subtraction. Okay, again, don't make it too hard. It's interesting looking. Okay. The addition and subtraction of matrices is associative. That has to do with grouping symbols. So you're going to treat your parentheses as kind of the same way you would with a regular plain old ordinary addition problem. It is also commutative. So that means you can change the order. It has inverses. Be careful with this word because the additive inverse is different from the multiplicative inverse of a matrix. So this is the additive inverse. This is the same thing as your opposite matrix. We have an additive identity property. So that means there exists a matrix where I can add it to any matrix and get the original matrix out. This is called the zero matrix. Okay, and the zero matrix is literally just a matrix with all zeros. Okay, so instead of like numbers like 11 and -12, it's just all zeros. Okay, that is your identity matrix. And then another one, which is something you may have heard of or not, is something called closure. Okay, closure property basically says that if I add a 2 by 3 matrix to another 2 by 3 matrix, I'm going to get a 2 by 3 matrix back out. So the addition of matrices is closed because if I add matrices of a certain dimension together, I'm going to get a sum or a difference of the same size. Now, this is an actually fairly important property. We will find that matrix multiplication is not closed under certain circumstances. So the fact that addition and subtraction is closed for matrices is kind of important. Okay. All right, the next thing, or the last things in this particular section is something it sounds really complicated. It's called a matrix equation. Okay, and all a matrix equation is you have two matrices. Let's say you have 3x, then 4y, 10, and 12, plus, let's say 7, negative 10, 10, 12, okay, is equal to 20, negative 12, 20, and 24. So I want to find x and y. Well, think about how you add matrices up. You add them by element. So this element plus this element should equal this element. So I can write an equation for x. 3x plus 7 is equal to 20. Then I can turn that around and find an equation for y. 4y plus a negative 10 is a negative 12. Just like that. And then I can just go ahead I'm going to get fractions here, but that's okay. It's negative 2. And there we go. So x is equal to 13 over 3, and y is equal to negative 1/2. Okay, so that is a basic, fairly simple matrix equation. Let's go ahead and do another one. Okay, so now you'll notice that I actually have 3 variables in here. So 3a minus 1 plus a 17 is equal to a negative 1. Okay, again, it's just kind of like matching things up. 15b plus 5 is equal to 18. Okay, last one. Let's see. Oh, there's negative 10c right there. Then the 12 matches up. And then the 14. Like that. So now what I can do is I can solve these guys. So let's see. I get 3a plus 16 is equal to negative 1. Subtract off the 16. I get negative 17. So a is negative 17 over 3. Okay, next one. 15b, subtract your 5. And that's it. Lots of fractions. Last one. Subtract off your 12. So I get negative 10 is equal to 2. Divide by negative 10. And then, oops, that's not x. Let's see. C is equal to negative 1/5 if I reduce. Okay, so adding and subtracting matrices, it can be, depending on the size of your matrix, a little bit time consuming, but yeah, it's not so bad, kind of fun.